According to academic digest once. So notice this value, this is 3 base. Is there any way I can get 3 from this? It's not possible. 3 does not have units multiple of 15. Like 3 does not do 3 raised to power anything to give you 15. It's not possible. 3 raised to power 2, 9. 3 raised to power 3, 27. So it's not possible. So, and the power here is not the same. Once the power is not the same, once power and base not equal on left hand side and right hand side, you simply introduce logarithm. So I'll take the log of both sides. So this is going to be, I'll use 2 methods to solve this. This is going to be the same thing as saying log 3 raised to power x plus 1 equals to log 15. And I want to make things easy for myself. So I notice that this 3 is the one carrying the x. So in order for me to have my x free, I'll make the logarithm to be in log of 3. This will be in log of 3. I mean, I'm free to put log of anything to both sides. So this is going to be the same thing as saying have obeying power law. What is this? So I'll have x plus 1. Then log 3 to base 3 is equals to, power law says that whatever I have as the power can move over. So this is now log 3, 15. So notice that what I have here is 1. So that means 1. So this means x plus 1 equals to log 15 to base 3. So I can choose to say this x plus 1 equals to log 15 to base 3. This is something as saying x is equals to log 15 to base 3 minus 1. And this 1 looks like something I know. This can be something as saying log 3 to base 3. So notice that. So minus log 15 to base 3. So and you remember why we did this, logarithm says that if I have this can be the same thing as saying x equals to log 15 over 3. So x is equals to log 5 to base 3. So another method I can use to solve this is simply, this is my final answer. So you find log 5 to base 3. Another method I can use to solve this is to say I have 3 raised to power x plus 1 equals to 15. I'll say 3 raised to power x times 3 raised to power 1 is the same thing equals to 15. You can say divide both sides by 3 raised to power 1. And 3 raised to power 1 is 3. So I have 3 raised to power x is equals to 5. Notice at this junction the base are not the same. The powers not the same. I'll introduce logarithm. Once base not the same, power not the same, introduce logarithm. And the logarithm I'll introduce here is that of 3. So that by the time this and this come together to give me 1. Notice that x can cross over. This becomes x log 3 to base 3 equals to log 5 to base 3. Yeah? Notice that this, everything here is 1. X is equals to log 5 to base 3. So this is your final answer. So let's take another question. Let's say I have 2 raised to power x equals to 5 raised to power x plus 2. Using the first approach, the bases are not the same. Is there any way I can make the bases to be the same? No. The powers are not the same. Is there any way these powers, assuming it's the same, I'll say equate the powers so that the bases are equal, but it's not the same. I introduce logarithm. Log 2 raised to power x is equals to log 5 raised to power x plus 2. This can move behind, so it becomes 2 log, sorry, x log 2. This logarithm is simple, but just carefulness, small thing you do like this change everything. So you need to be familiar with the formula. So this thing now, this is the power, can move. So the power law says that whatever you have as the power can become your coefficient before the logarithm. So x plus 2 log 5, this sign. So notice that I already have x this side. And if I say divide both sides by log 5, you see that this side I'm having x plus 2. Let's just try it one side so that we'll come back, see what I mean. So we use this side to solve the main thing. We use this side to practice, like your wide imagination. Let's see our wide imagination if it works. So we can say divide both sides by log 5. So I have log 5 over log 5. So I have x log 2 over x log 5, over log 5 equals to x plus 2. So notice that I can choose to say this is plus, Shebi. I can choose to say x now becomes x. You see that I still have that x, which is what I'm avoiding. That is what I'm avoiding, because I'll have x here, have x here. And if I say x log 2 now, all over log 5 minus 2 equals to x. Even if I say take the log of both sides to be 2, you see that I still have x minus 2 over log 5 equals to x. So it doesn't fit in well. So that's where you use what we call knowledge of experience. So you need to look at this box. So you need to look at this box and notice that I am using log 10 here. Reason being that since this one is carrying 2 raised to power x, this one is carrying 5 raised to power x, I don't want to give the log to anyone to make anyone become 1. So that's why I'm doing that. Assuming, let's still use this for our wide imagination. Assuming I did this side to be log 2 base 2, and this is now x. This will become x equals to x plus 2 log 5. You see that it still doesn't clear my problem, because if I do this now, this will now be x minus x. And when you don't have x, what are you now solving? So that is why I am not going to use any of this. Why I did this is because most of you students, this is the way you think. So you need to pay attention. Everything here plus 2 can be multiplied by this log, because it's multiplication that is separating them. So I will do x log 5. So mathematics, forget the fact that people solve mathematics, it looks easy, they solve on YouTube. What mathematics is naturally, what mathematics is meant to be, something that if you know it, if you know the concept, you use your materials, analyze which one works out the answer. That is why anything you solve mathematically will give you an answer. But the key thing is you're able to solve, analyze it, and see the one that gives you correct answer. Notice we've tried everything and we've seen that it's not tallying. Not like we can manipulate it, but we need one that suits the principle. So log 5 times x plus 2 log 5 is equals to x log 2. So at this junction, I can simply say collect the like terms. So that this becomes x. Watch. This is x, this is x, should be xx. So I can just say, bring it in such a way that I have the common term, or let me do it this way. x log 5. Sorry, x log 2 minus x log 5, that is crossing over, equals to 2 log 5. So this is the same thing as saying more like 2m minus 3m. So the m here is the x. So you can see that I'm using 5. Let's say this is 5m, this is 2m, or you say m2 minus m3. This is what it means. You see that what will happen is that you will just have minus m. The m is still there. So that is the same idea that we have here. So the x is simply going to the sentence and saying x into log 2 minus log 5 equals to 2 log 5. This still requires you practicing, great knowledge of it. And notice that everything I have here indices gives me that this is something I'm saying x log 2 over 5 is equals to 2 log 5. Let's see it. Indices. So this is going to be the same thing as saying x is equals to 2 log 5 divided by log 2 over 5. And notice this log is in the same base, which is 10. So this is the same thing as saying bring out just 1, since they are the same thing. It's just like I have a raised to power 2 all over a raised to power 3. Just bring out 1a, do everything. All those kind of concepts. So since the logs are the same, bring out the log, do everything. So this is the same thing as saying 2, or you say this is the same thing as saying log 5 raised to power 2. Notice the power now will move up, all over log 2 over 5, which is the same thing as saying log 25 over 2 over 5. And notice this is fraction dividing whole number. This is something as saying log I don't want to apply that indices so I don't confuse it. There's an indices I could have applied, but let me just leave it at this. Let's leave it this way so you don't get confused, you don't get carried away. Let's leave it this way, log. Let's retain the logs. So we obey in logarithm. There's something I could have done, but if I do it, you might get carried away. So this is going to be the same thing as saying log log 25 all over log 2 minus log 5. If you remember division. So this is your final answer. Once you're able to get log 25, do log 2 minus, you get your final answer. So we should give you minus 3 points thereabouts. Okay, so that's to go with this, the first method. So but assuming I want to employ the second method I told you we can use, I'll simply say, as I see this 2 raised to power x equals to 5 raised to power x plus 2, I'll simply say this is the same as saying 2x equals to 5 raised to power x times 5 raised to power 2. This is the same as saying, since it's x I'm looking for, I'll divide both sides by what is carrying. So 2 raised to power x divided by 5 raised to power x equals to 5 raised to power x times 5 raised to power 2. Let me use dots so you don't confuse it. All over 5 raised to power x. This will cancel this. So I now have 5 raised to power 2 is equals to 2 over 5 raised to power x. And this is going to give me the sentence as saying, since the powers are not the same and the bases are not the same, This is 1 over 5 times 2. It's not the same thing as saying 5 raised to the power minus 2. This is 1 over 5 times 2. 5 raised to the power minus 1 is not the same thing with 5 raised to the power 2. So for that reason, I introduce logarithm. So, and logarithm I will introduce is the logarithm to this base. So log to base 2 over 5 x equals to log to 2 over 5, then 5 raised to the power 2. This log and this will give me 1. So x, they will cancel. So x will be equals to log to base 2 over 5, then 5 raised to the power 2 is 25. So that I now have the principle of reciprocal in logarithm. This is something I'm saying x equals to 1 over. Once you introduce this reciprocal, even if I have log a raised to base b, this is the sentence I'm saying 1 over log to base a b, reciprocal. Once you take reciprocal of something, for example, a over b is the sentence I'm saying 1 over b over a. You need to know that reciprocal. So for that reason, if I introduce it, this is the sentence I'm saying log to base 25. Then log of 25, log of 2 over 5 to base 25, and this is the sentence as x is equals to 1 all over log to base 25, log 2 to base 25 minus log 5 to base 25. This is the sentence. Or I can also use x is equals to, at this point where I have log 25 to 2 over 5, I can say x. These are laws of logarithm I'm applying. Just the one that is here, log 25 all over log 2 over 5. And you know that this is the sentence I'm saying x is equals to log 25 all over log 2 over 5 minus, log 2 minus log 5. All these things you see me applying are laws of logarithm. Reciprocal law, that's what I employed here. The same thing here, inverse law. So if I know this is the same thing I got here. So when you do it, you get your answer. Thank you very much. Notice that this one now, this place I did or, this is when I have this to be the base. So I do take the logarithm all over the logarithm of this one. And notice that if you do it in this case now, the minute you take this reciprocal, what you are now introducing at this point is now a base of 10. At this point, anytime you are having log without putting anything at the base, know that it's in base 10. So thank you, subscribe, like and share.